Hi, good evening, everyone. So, today I'm going to take questions from 31 to 45 onwards, right? And I hope that you have already tried them at least once before we discuss these questions. Um, on Friday, I will be taking the last session of this that will cover question number 46 to 60. So, again, tomorrow's time you will take to just do these questions yourself. And then on Friday, we will meet again and I will go ahead and I will do question number 46 to 60 in that session. Let's start with the first question. Just make sure that you see that question number 31 to 40, these are MSQ questions. So we will have more than one answer that is going to be correct. Right, beta? Okay, let's start. It says, suppose that the utility function represents a complete transitive and continuous preference relation. Sometimes in exam, if you are not sure, about a general utility function, मतलब ये बहुत ही it seems very difficult कि मैं क्या utility function assume करूं, कैसे करूं इस तरीके के क्वेश्चन को. You can always in your mind rewrite the utility function in a way which follows these properties. So हमें पता है कि एक Cobb-Douglas utility function it follows completeness, transitivity, continuity. वो तो well defined है. तो अगर मेरे को ये general utility function समझ में नहीं आता, for example, I am not able to get what this general utility function is. In that case, you can take your Cobb-Douglas utility function safely. क्यों? Because we know that it follows all these properties. And this is what is given to us in the question. Secondly, if you feel that, देखो ध्यान से try to understand this thing. This says it goes from Rn plus to R plus. Rn plus means I am consuming n goods. Good 1, good 2, till good n. And then I am getting one answer. One answer. That becomes my utility. जो भी मेरा आंसर आ रहा होगा वो मेरी यूटिलिटी है. ये जो कंजम्पशन यूनिट्स होंगे, all of these will be positive. So there is a plus here, non-negative actually. And my utility that I will get, that will also be non-negative. ये भी positive होगी. It has to be non-negative. It can be 0, but it cannot be negative number. This is what it is saying. Now try to understand that you can also take this one level up. मतलब जरूरी नहीं है that I have to go ahead and work with n goods. I can rewrite this entire problem and I can just take n to be 2. तो भी कुछ गड़बड़ नहीं होगी because I am just assuming my n is 2. The question says you have to do it for n goods. But what is the value of n? I can just reconsider it. So what I can do is that I can say that my utility function is simply x1 into x2. So I've assumed that my n is 2. And I have taken this utility function in particular because this is the simplest one. मुझे इसको solve करना easily आता है and I know that it satisfies all these properties. Completeness, transitivity, continuity, वो सब कुछ satisfy कर रहा है. It is satisfying all of these. That is one thing. Now it is very easy to see. देखो, look into the first aspect, beta. So you are saying that your utility function is now, अगर मैं पहले function के हिसाब से लिखूं, so it says it is utility function plus the cube of the utility function. So my utility function is x1, x2. I will write this as f. x1, x2. And plus I am doing the cube of x1, x2. So x1, x2 to the power 3. This is how you can go ahead and you can write this utility function. ये आपका पहला part हो गया. Now, if you go ahead and you look into the second kind of utility function, it says u plus summation of x1, x2, which means that the function that I will be forming, this function will be x1, x2 plus sum of the x's. And I have taken n as 2. So it is going to be x1 plus x2. Right? Look into the third utility function. U ka power is 1 to the power 1 by n. So n is just 2 for me. So my third utility function becomes x1, x2 to the power n is just 2 that I have taken. So it will be to the power 1 by 2. And the last utility function that I have, that utility function basically m. This is u plus this part. So it will be x1, x2 plus, I can just go ahead and assume this to be x1 square because there are n, but I just have to take 2. So x1 square plus x2 square to the power 0.5. This is how you can go ahead and you can write all these utility functions. अब हमने क्या किया है, हमने इन सारे utility functions को rewrite कर लिया है in such a way that this is easily understandable. I can easily understand these utility. Right. Acha, now, acha, this is to the power 3 only, na? The first one. Okay. So now what you can go ahead and you can do is, now the question is asking which of the following functions represent the same preference relation as the utility function that you have written. So try to see that for the first utility function, जब मैं इस utility function की बात करती हूँ, if I try to go ahead and I try to find out the MRS of this function, it is going to be mu1 by mu2. And if I differentiate this with respect to x1, I will get here x2 plus 3, x1, x2 to the power 2 into x1. And if I differentiate this with respect to x2, I will get x1 plus 3, x1, x2 to the power 2 into x2. This is what is the answer that I will be getting. Now, can I go ahead and simplify this somehow? क्या मैं इसको किसी भी तरीके से better off करके कुछ और करके लिख सकती हूँ? No, this is going to be my final MRS that I'm going to go ahead and get. Now look into the second one. When I look into the function g and I try to find out the MRS, what will be the MRS? MRS will be mu1 by mu2. So if I differentiate this with respect to good 1, I will get x2 plus 1. Differentiate this with respect to x1, you will get x2. Here you will get plus 1. And when you differentiate it with respect to 2, then you will get x1 plus 1. So here also you will get x1 plus 1. Differentiate the third one. Find out its MRS. Its MRS will simply be again mu1 by mu2. So if I differentiate with respect to the first one, x1, I will get half. x1, x2 to the power minus half into x2 upon half x1, x2 to the power minus half into x1. So my MRS is going to be x2 by x1. And just check the last one. So if you just differentiate and find out the MRS, you will get mu1 by mu2. Differentiate it with respect to 1, you will get 1 plus 0.5 x1 square plus x2 square to the power minus 0.5 into 2x1 upon 1. So this is x2, huh? Upon x1 plus 0.5 x1 square plus x2 square to the power minus 0.5 into 2x2. These are your MRS that you will be getting in this case. Right? These are your MRS. In F, can't we take x2 common in the numerator and denominator? Here, in the first one, we can. Yes, we can take this, of course. You can go ahead and you can simplify in that sense. So this is going to be 3 x1 square, x2 square, x1 upon x1 plus 3 x1 square, x2 square into x2. So if you want, you can definitely take x2 common, but that won't change anything. So it will be 1 plus 3 x1 square, x2. This will be simply x1 cube Upon if I take x1 common, it will be 1 plus 3 x1 into x2 cube. But that won't change anything, na, even if I take common.
Ma'am, in the first part, we are differentiating with the x1 now.
We are differentiating with respect to x1 here, yes. And with respect to x2
So,
here.
so 3 to the power x1, x2 whole square into x2 it would be, no?
Yeah, sorry. My bad. This will be x2. You're right. This will be x1.
Yes,
Now you
ma'am.
can take common. Correct. Right. So this will be plus 3 x1 square x2 cube. And this will be x1 plus 3 x1 cube x2 square. So if you go ahead and you take x2 common, you will get 1 plus 3 x1 square x2 square. And if you take x1 common, you will get 1 plus 3 x1 square x2. Yes, then it will cancel out. Correct, correct. This will be also x2 by x1. So you have gone ahead and you have found out the MRS of all four. Now, we know the property that whenever the question says that does it represent the same preference or not, then representing same preference just means monotonic transformation. And monotonic transformation ideally just means that they will represent same preference if my MRS is equal. So my initial actual utility function that I had taken was this, u is equal to x1, x2. And we know that if I find its MRS, this will be mu1 by mu2, and this is going to be x2 by x1. So the MRS of this initial utility function, this is x2 by x1. The MRS of this first function that I had altered and formed, that is also coming out to be x2 by x1. The MRS of the second utility function is not coming out to be x2 by x1. We just saw that its MRS is coming this. The MRS of third utility function is again coming x2 by x1. And the MRS of the fourth utility function is again not coming to be x2 by x1. It's not coming. So we can say that the only two utility functions which represent the same preference as the original one are A and C. And that's the answer to this question. So I hope this is making some sense to you. See, the question is asking me which function represents the same preferences. In order to check the same preferences, you need to prove that they have the same MRS. We could have gone ahead and we could have solved this question indirectly also. Matlab, keeping the function as it is also, I could have done it. Just for example, if I was given that the function is u plus u cube, यही function दिया हुआ ना मेरे को, u plus u cube. This one, first one, u plus u cube. I could have tried to do it as it is also. Ki theek hai, this is a function of all x's. This is also a function of all x's. So, I would have differentiated this with respect to f1 and f1 done. But I somehow always find that when you explicitly mention the function, things become much easier than doing the question implicitly. So it is a good idea that you take some function, koi ek function le lo, take some utility function, and then just go ahead and try to solve that. That will make things very easier for you. Now, let's go to the next question. So the next question that I want to take is question number 32. See that here I'm given that this is a max function. So what is the utility function given to me? Utility of individual 1 is given to you as max of x1, y1. And utility of individual 2 is given to you as max of x2, y2. You're given that the aggregate endowment of good x, that is given to you as 30 units. And aggregate endowment of y, that is given to you as 10 units. Which means that in this case, I am not going ahead and forming a square Edgeworth box. This is going to be a rectangular Edgeworth box, and we will have to go ahead and solve this accordingly. So what do? I make just 1 second. Let me just create some space. So I just go ahead and I make this Edgeworth box. And I will mark some important point here just for the understanding. What will I do? This is 0. I will take this as 10, 20, and 30. And this is origin of individual A. This is origin of individual B, beta. This starts 0 from here. So here it will be 10. यहाँ पे जहाँ पे ये 20 है ना, it will be 10 here. Here it will be 20, where it is 10 here, wherever this is 10 here. Right? And then you will be having 30 here. These are important points. Now we know that I must, whenever we plot any max function, max of xy, we must have one kink, right? So if this is x and this is y, and this is y, I need a point of kink. So, I can have 5 here and I can have 5 here, and this will be my point of kink, and then I will draw an inverse L shape. So all of them, these kinks, or I can say these edges, they are going to be across the line x is equal to y. On that implication, I can say that if I have 10 here, beta ye to 10 hai, and I know that this width that I'm talking about, y ka 10 hi hai. So this represents 10. For a diagram, just make it a little sober. Matlab, this and this should be equal to each other. Both of them are representing 10. Let me just make it a bit lower. This is better. This is 10, 20, 30. This is 10. This represents 10 and this much is also 10. So we know that I must go ahead and draw a line here. And for individual A, all his indifference curve must be on this line, right? So I'm going to go ahead and draw that. This is the IC of individual A, second IC of individual A, third IC. Similarly, when I talk about individual B, then his ICs have to be also on that point of kink only. So what will I go ahead and do? This is 10 for him, and this is 10 for him here. So I will draw a line of kinks here, and then I will say that it has to be also L-shaped only, na beta? So it has to be like this, because this is his origin. So around his origin, I have gone ahead and drawn all his ICs, like straight lines. Now, what is the question asking you? The question is asking you, please, aggregate endowment is given. Select the choices which are Pareto optimal. So you have to tell which points are Pareto optimal in this economy. So we have done 3 ways to find Pareto optimality, out of which the first way tells you that you will hold the IC of one individual constant. So let's say I am holding the indifference curve of B constant, and then I'm trying to go ahead and find out the highest IC of individual A. So I am fixing his IC to this. I am saying, look, for individual B, I am fixing his indifference curve to this one. Which is the highest IC that individual A can attain? Right? This is what the question is. So just try to think about it. If I just in my mind try to extend this a bit, that extension is not possible. But suppose we extend it, तो यहाँ पे जो point 11 रहा होगा, it must have met somewhere here. So this IC, this much part I can show within the Edgeworth box, but that dotted line I cannot show on the Edgeworth box. Similarly, this IC which represents 12, 12 ka point, this is his next IC. Some part is outside the Edgeworth box, but this part is within the Edgeworth box. Similarly, if I just keep doing this, there will be an IC of individual A, which will pass through his kink point of 20, 20. But this part of that IC, this will be outside the Edgeworth box, and this will be within his Edgeworth box. So the highest point that he will be able to attain, the highest IC that he will be able to attain will be this IC. This will be the highest IC that A attains, right? Out of which the only part which will be within his Edgeworth box will be this part, this entire part. That will be within his Edgeworth box. And the remaining part will not be as part of his Edgeworth box. That is the first thing that you have to understand. So that is how he can go ahead and he can find out the highest IC he achieves given the IC of individual B. Now, the points that you are given, most of these points, if you go ahead and you notice, look here, these points represent the origin points. So, if I fix the origin of individual B, that means I fix his utility at 0, then what can individual A do in that case? He will continue moving to the highest IC possible. So he will go ahead and he will continue doing the same thing like this. Some part definitely will be within his IC, within the Edgeworth box, and some part will not be part of his Edgeworth box. But this is what he will continue to do, right? So the highest IC that he will be able to attain here, it will go ahead and it will meet this axis. It will be part of this axis. But the only thing is that a lot of the part of the IC will be outside the Edgeworth box, which we cannot help. We just have to look which part of the IC will be within the Edgeworth box, the highest IC that he will be able to attain. Now, the function given to me is a max function. So from max function, another thing that is clear to me is that this individual cannot consume both the goods. Either he will be consuming all of good X or he will be consuming all of good Y. So on that basis, once individual A has attained his highest IC possible, either he will be here, right, where he is going ahead and consuming all of good X, or nowhere else. Because anywhere here, if he is here, he's consuming a combination of X and Y. Here, he's consuming a combination of X and Y. Here, he's consuming a combination of X and Y. So this point for individual A, it matches to the point where he has 30 units of X and 0 units of Y. And correspondingly, this point for individual B, it matches the point where he has 0 units of X and 10 units of Y. So this becomes one of the Pareto efficient points. So this is what is given here. This is your Pareto efficient point that we have attained. Now we can go ahead and we can do the reverse also. So if I just remove all of this and I reverse the concept, right? And I ask you, okay, look, now I'm asking you, which is the highest IC that B can attain? So all the ICs of B, he is going to have ICs in the shape such that this is his origin. So this is one of his ICs that he has attained. This is his IC. And then if I just extend this point of king, although a lot of that will lie outside the Edgeworth box, we are going to have this, 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 and he will continue doing so. Like this. He will continue doing so, right? So the highest IC he will be able to attain will be this IC, this IC. And this is going to go ahead and match this axis, right? Other part will be outside the Edgeworth box. And on that basis, he will again, individual B will again get 2 points. Either his point will be this or his point will be this. Now here, individual B is consuming sum of X and sum of Y, which is not possible. This is a max function. So which means the only point where he consumes one good completely is this point, where he is consuming all of good X. And correspondingly, individual A gets to consume all of good Y. So this point also represents another Pareto efficient point where consumer A is consuming all of good Y and B is consuming all of good X. So this gives you another Pareto efficient point. There is another very simple way of looking into it. But you are given a max function. In a max function, we know that you cannot have the consumption of both the goods. Simple. You cannot consume both the goods. तो उस हिसाब से यहाँ पर तो 10,10 आ रहा है, which means individual A, the first individual is consuming 10 of one good and 10 of the other good. This is not possible. This is incorrect according to the max function. Same here. He's consuming 5 of X and 5 of Y. This is not possible. They should either be consuming all of X or all of good Y. That will give them higher utility. So even on that basis, just by looking on that basis, that this is a max function, we will be able to go ahead and tell that these individuals should not be consuming both the goods, right? So the only option where each of them consumes one of each good, that is option number C and D. So on that basis also, we can go ahead and say that C and D are the correct option. That's the answer to this question. Okay. So just try to think this intuitively. Draw a diagram and see. That will go ahead and help you solve such questions. Okay, let's go to the next one. Very good question. Here what they have done now, they have given you 3 players. Player 1, 2 and 3. And they're saying in a 3-player game, player 1 can choose either up or down. Player 2 can choose left or right. That's clear to us. And player 3 can choose either table 1 or table 2 as strategy. तो पहले हम बात करते हैं table 1 की. This is table 1. Within table 1, within देख रहे हैं बेटा अभी. तो मतलब player 3 is out of picture for now. Within table 1, I am not comparing table 1 with table 2. So player 3 is nowhere. Within table 1, हमें देखना है what is the best strategy possible. So here you are given player 1. Here you are given player 2. This is left, right. And here you are given up and down. This is within table 1. And what are the payoffs that we are given? We are given 3, 2, 5. We are given 4, 1, 3, 2, 6, 1, and 5, 4, 6. But for now, the payoff of player 3 are useless. क्योंकि player 3 तो तब picture में आएगा when I will compare table 1 with table 2. As of now, I am just going to solve this as is. जैसे हम पहले कभी भी अपना Nash निकालते थे. So I will hold the strategy of player 2 constant at L and compare for player 1. His strategy is the first payoffs. First. That means 3 or 2. 3 is greater than 2. So I will mark 3. Then I will go ahead and I will look if what happens when player 2 chooses R. Again, I will compare between 4 and 5. Clearly 5 is greater. Then I will go ahead and I will choose player 2 strategy at up. And I will see what player 2 can do. He has to compare between 2 and 1. Clearly 2 is more. And when player 1 fixes it to down, then again player 2 has to choose. So between 6 and 4, clearly 6 is greater. This is within table 1. Table 1 के अंदर हमने अभी देख लिया है. Within table 1. Similarly, you will check what happens within table 2. I am not comparing tables. So player 3 का कोई relation नहीं है. Do it usually. So this is player 1. This is player 2. Within table 2, player 2 can again choose left, right. Within table 2, this is up and down. And the payoffs given to us are 2, 3, 4, 4, 5, 7, 6, 4, 0, 3, 3, 3. And again, I will compare same player 1 or 2 ka. So fixing player 2's strategy to left. What is best for player 1? You will compare 2 and 6. So I have 6. Fixing it to right, what is best for player 1? You will compare 4 and 3. So 4. Fixing player 1's strategy to up, you will go ahead and compare for player 2. So within 3 or 5, 5. And between 4 and 3, so 4. Now this, abhi tak it has been the usual way. Like we usually go ahead and find Nash equilibrium. Table 1 ka Nash I have found out separately. Table 2 ka Nash I have found out separately. And that Nash is based on how player 1 and player 2 are acting. Now, it says that player 3 can choose either table 1 or table 2 as strategy. मतलब player 3 किसी की basis पे नहीं कर रहा. He is not choosing his strategy by fixing player 1 या player 2 का strategy. Player 3 is comparing table by table. So he is comparing कि अच्छा, is 5 greater or is 4 greater? 5 is greater. Then he is comparing the second cell. Is 3 greater or 7 greater? 7 is greater. Then he is comparing the third cell. Is 1 greater or 0 greater? 1 is greater. And then he is comparing the fourth cell. Is 6 greater or 3 greater? Clearly 6 is greater. So I see that this completely is colored out and this is colored out. So I have got 2 Nash equilibrium in these table. I have got the first equilibrium that in table 1, we see up and left. And in table 2, I see up and right as my Nash equilibrium. And that's how you can go ahead and solve this kind of question. So try to see. जब हमने player 1 और player 2 को compare किया, that I have done usually, like we have seen in multiple game theory questions. You will compare by holding the strategy of the other player constant. Player 1 को hold किया constant, player 2 के लिए best, 2 को hold किया constant, 1 के लिए best. Till then it is everything is the same. Then the question is going ahead and asking you that what happens when player 3 compares. And how is player 3 comparing? Player 3 is comparing on table basis. So he will go ahead and compare each cell by cell based on his payoff. And wherever you see that that is matching, that is going to be your Nash equilibrium. Right? So this is how you can solve it. So your answer will be A, up left table 1, and D, up right table 2. That's the answer to this question. Okay, come to the next question. This question is asking you to go ahead and check whether the function is this is every year question, okay? Asked every year. Fixed question. This year also you will see this question in the paper. हर साल ये question आएगा ही आएगा. They will give you a 2 variable function. They will ask you to check continuity and partial differentiation, partial differentiability.